Hello, my friend. Thank you for tuning in. Now, in this discussion, we are going to be looking at how we can answer the following questions. So, given a bridge for wave rectifier below, okay, answer the following questions. What is the peak output voltage of the circuit? What is the average DC output voltage, and what should be the minimum PIV rating of the diodes, what is the VRMS value, ripple factor, form factor are all to be calculated. And the input signal has an amplitude of 25 volts and the minimum, of course, of negative 25 volts. So the transformation ratio is 1 to 1, meaning the output is equal to the input. That's all. So what else? We are also given that these are real diodes with the voltage drop of 0.7 volts. So in some cases, they can say these are silicon diodes. So when they say they are silicon diodes, you have to remember that these are real diodes and therefore there is a voltage drop of 0.7 volts. So let's begin. What is the peak output voltage of the circuit? So the peak output voltage, therefore, is going to be what? So what is going to be measured at the output as peak, or the maximum peak voltage that is going to be measured is V peak, which is equal to, now we have said that the amplitude of the signal entering or the power entering is 25 volts. So meaning we are going to be having 25 volts. But remember, for a full wave bridge rectifier, we have two diodes conducting at a go. So we are going to subtract, okay, 2 times 0.7. And this is going to give us 25 minus 1.4. So that is 23.6 volts. So that is the peak output voltage that is going to be measured at the output. And what is the average DC output voltage? Therefore, the VDC, remember, for a full wave rectifier, is 2 Vm or V peak divided by pi. So this is 2 times 23.6 divided by pi. So divided by pi, this gives us 15.02 volts. So we have finished that. So let's go to the next. What should be the minimum PIV rating of the diodes? So since we have for full wave rectifier and especially the bridge full wave rectifier, PIV should be greater than or equal to V peak, or what we call Vm, the maximum voltage. And since our we said that for this maximum, I mean for PIV, which is the maximum reverse voltage that a diode is going to withstand, when we do the calculations, we find that it should be PIV greater than or equal to V peak when we have the voltage drop across the diode when it is zero. But when it is a real diode, as we have been told, then PIV must be greater than or equal to V peak minus 0. Minus 0. So this is going to be a V peak, which is 23.6 minus 0.7. 3.6 minus 0.7, this gives us 22.9, and therefore the rating of the diodes should be at least greater than or equal to 22.9. That should be the minimum. And next, we are required to find the VRMS value. We know that VRMS value for a bridge or full wave rectifier, this is equal to, we said we have VM or V peak divided by square root of 2. That is for a full wave rectifier. This is the same as V peak divided by the square root of 2. And our V peak that we have above is, the V peak that we have above here is 23 point, this is going to be 23.6. So 23.6, yes. Now divide by square root of 2. So 23.6 divided by square root of 2. So the VRMS value will be 16.688 volts. So let's proceed and look at the next, which we called the ripple factor. So we are told to also get the ripple factor. So ripple factor is the ratio of VRMS value to VDC, or the average DC output voltage. And this is going to be, we already know that the VRMS is 16.688. We divide it by the VDC. So VDC is 15.02. So 15.02. So if you get 16.688 divided by 15.02, we get around 1.11. So for full wave rectifiers, we already know that the ripple factor is 1.11. Let's look at next, which is the form factor. So form factor, we know that form factor is going to be square root of VRMS divided by VDC, everything squared, minus 1, and that's all. So what is the form factor? This is going to be, first of all, we have 1.11, okay, which is squared. We take away 1, then we get the square root of that. So 1.11 squared minus 1, we take square root of the answer. We find that this is always approximately 0.48. So for all full wave rectifiers, we find that the form factors are about that. And we shall see that actually for a half wave rectifier, that the form factor is big. So it is going to be a square root of, if the ripple factor is 1.57, we square, then minus 1. So that value is 1.57 squared minus 1, we take root. So you find that for a half wave rectifier, the form factor is about 1.21. So you can see that for it, a half wave rectifier has got many ripples. In other words, there is a large value of vibrations. You expect more vibrations in the output compared to the full wave rectifiers. Hi everyone. In this discussion, we are looking at a form factor and ripple factor for rectifiers. We'll be looking at full wave and half wave rectifiers. So ripples are the oscillations that are obtained in DC, which are corrected by using filters such as inductors and capacitors. These ripples are measured with the help of the ripple factor and are denoted by gamma. Ripple factor tells us the number of ripples are present in the output DC. So the higher the ripple factor, the more is the oscillation at the output DC, and lower the ripple factor, the less is the oscillation at the output DC. We will see that the ripple factor is the ratio of the root mean square value of the AC component of the output value voltage, the DC component of the output voltage. So ripple factor RF is equal to VRMS out of VDC. So let's look at for half wave rectifier, we'll see that the ripple factor is going to be VRMS. VRMS for a half wave rectifier is the same as Vm divided by pi. No, this is Vm divided by 2. So Vm is the peak DC voltage, or what would be the same as the peak AC input, or the peak of the input AC voltage. So now this is divided by, if we got VDC, VDC is the same as Vm divided by pi. So what will this be? This is going to be Vm divided by 2 times pi divided by Vm. So when this and that cancel, we'll have finally the ripple factor for half wave rectifier will equal to pi out of 2, which is the same as 1.57. So the ripple factor for a half wave rectifier is very high as 1.57. So let's look at the ripple factor for full wave rectifier. So we know that this is the same as VRMS out of VDC. VRMS for a full wave rectifier is the same as Vm divided by root 2 divided by root 2. So if we multiply it by, okay, let's divide it by Vm, okay, Vm divided by pi, but 2 times. Remember, the average DC output of a full wave rectifier is twice Vm divided by pi, and this is equal to Vm divided by root of 2 times pi divided by 2 Vm. So what is that going to be? If I get pi divided by 2, then I divide it by root of 2, I have the RF for full wave rectifier equaling to 1.1. So that's where the 1.11 comes from for the ripple factor for a full wave rectifier. So let's look at the form factor. Form factor is also the ratio of RMS value, the DC value, but this is how we calculate it. Form factor is equal to the square root of VRMS squared minus VDC squared, everything divided by VDC. So this becomes square root of VRMS squared, okay, minus VDC squared divided by VDC squared. If I do it like this, then it still means this. So what does that mean? I can still say form factor is equal to square root of VRMS squared divided by VDC squared, okay, minus VDC squared divided by VDC squared. So this is the same as square root of VRMS divided by VDC squared minus 1. So what is that going to be? So for half wave rectifier, form factor is going to be, we said, VRMS divided by VDC is the same as ripple factor, which is 1.57. So we shall have square root of 1.57 squared minus 1. So 1.57 squared minus 1, I take root, so I will have 1.21. That's the form factor for half wave rectifier. So for full wave rectifier, form factor is equal to square root of VRMS divided by VDC squared minus 1. Remember, VRMS divided by VDC is the same as ripple factor, and ripple factor for full wave rectifier is 1.11. So this is going to be square root of 1.11 squared minus 1. So 1.11 squared minus 1, I take root of the answer, I have 0.48. So form factor for full wave rectifier is equal to 0.48. So this is where the 0.48 comes from. So in this video, we have seen how we can get the form factor for both full wave rectifier and for half wave rectifiers. Thank you.